Okay, let's finish up 6.5, which is all about kites. All right, let's draw a kite first. It's easy to draw a kite if I put one line here and one line here. That's pretty good. I'm actually going to get rid of those 2 lines in a minute, but they're going to come back. We're going to use them a little bit later. Okay. Oh, that wasn't very good. Let's make this hit right there. There we go. And let me just copy that and group it so I can move it around when I need to. All right, a couple things. Actually, I don't want to group it. Not yet, because I want to get rid of a couple things. Let's see, how do I ungroup it that way? All right. So let's get rid of this thing. Let's get rid of this thing. All right. And so there's a couple things. We got like 3 or 4, let's see, 1, 2, 3 theorems. 3 theorems. This is the first one. And we're going to write these down. They're not too long. They're not too complicated. So we'll write them all down. So this one says exactly one pair of opposite angles. Just shorten that a little bit. Kite. All right, that's what we got right there. We got a kite are congruent. Or you could say equal or congruent. Okay? And let's label this. In my notes, I made this WXYZ this time. And it's a kite. Before we talk about this theorem, let's go back to remember what we learned about a kite. We learned on a kite, it's got 2 pairs of equal or congruent sides, okay? But they're the ones, they're not opposite each other. The sides opposite each other are definitely not equal to each other. It's got 1 pair of sides equal to each other right there, and it's got another pair of congruent sides right there. So that would be a kite, all right? That's what we've learned, okay? I don't know if we've learned anything else about a kite than basically the definition of it. I can't remember. I should have looked back to see what we learned about a kite earlier. But that's all we need to know right now, okay? Everybody got that? So now, what does it say? It says exactly 1 pair of opposite angles in a kite are congruent. So we got 1 pair of equal angles, okay? And then we got another pair that they're what? Not equal. Got it? Which ones on here do you think are equal to each other? The X and the Z. Very good. So this angle right here and this angle right here are the ones that are equal to each other. How did I know that those were the ones that are equal to each other? Well, they're the ones between the 2 non-equal sides. Everybody got that? You writing this down? If you're writing it down, it'll help you keep awake. All right, for those that are nodding off, write this down. Okay? So these 2 angles are equal to each other. What's true about angle W and angle Y? Are they equal to each other? Look what the theorem says. Exactly 1 pair are equal. That means no more than these 2. So tell me something again. Let's ask the question again. Are W and Y equal to each other? No, they're not. Okay, if these are equal, these 2 are what? Not equal. Got it? All right. That's what that theorem says. It's as easy as that. Now, there's a proof that goes along with it, but we're not going to do that. But that's good right there. All right? So if this was 120 degrees, I'll make this super easy. What's angle Z equal to? 120 degrees. They could also do stuff like this. Don't write this part down. I'm just making this up off the top of my head. What if this was like 3x minus 1 and this was 2x plus 2? Then what would you do? You'd set them equal, solve for x, plug it back in. You know the drill, right? Okay, so that's what you would do with that. All right, enough of that. Let's move on and do this. They take this kite and they flip it up like that. Doesn't really make any difference, but that's how they do this next one. So, yeah, that's what we'll do there. Okay, here's another theorem. Let's write that down. Theorem. It talks about the diagonals. Which ones are the diagonals here? The ones going through the kite. See that? Those are your diagonals. And it says the diagonals of a kite, are, okay, here's a word we've heard before, perpendicular. Well, last class had a bit of a time remembering what perpendicular meant. Hopefully somebody in here remembers what perpendicular means. What does it mean? The diagonals of the kite. This is one diagonal. See this straight up and down line and this one going across? They're both diagonals. If they're perpendicular, no. Side by side, I think you're thinking parallel. So look, it seems like every time I put these markers up, everybody gets it. I don't know why. This is parallel. Okay, what is it? Nah. No. I guess you guys... Have I not taught perpendicular? I know I have. I have. You're right. I have talked a lot more about parallel, but I've definitely talked about perpendicular. All right? If two lines are perpendicular, what are they? They're not like this. They're 90 degrees. You got it. See, it was in your head. It was in there. Do you remember that? Okay? So look at the markers up here. This is perpendicular. Everybody looking? Okay? Get it through your head, right? Get it through your eyes. And so now you got something visual to think back on, right? So when you see the word perpendicular, you're thinking what? How many degrees? 90 degrees. Got it? So what does that have to do with this? It says the diagonals of this kite are perpendicular. So guess what's true about, see, there's one diagonal, there's another one. How do they hit? They hit at a 90-degree angle. They're perpendicular. Make sense? All right. Is it coming back to you, perpendicular now? All right. I got to make a mental note next year to hit perpendicular a lot harder because that's something I thought you would know right off the bat. So that's what your theorem says. All right. That's all it says. You just make a right angle. All right. When you have the diagonals of a kite. We go to that? All right. We got another theorem. And this next theorem, you could kind of make it into two theorems, but they put it into one. So there's two things that we're going to know about this. Oh, by the way, before I do the next theorem, let's talk about a couple words. These are words we have not talked about before, so this is brand new. But it's gonna name these diagonals. It's gonna name the diagonals. So remember, if it's a kite, those two are equal and these two are equal. Agreed? All right. So this one, let's talk about this one first. I'll just put an arrow. See this one that's going up and down like this? Now, not every time is it going to be going up and down because I could have taken that kite and twisted it, right? Could have been kind of sideways. It could have been like left and right. All right, but this one right here is called the axis of symmetry. Sounds fancy, doesn't it? Yesterday, in my Algebra 2 class, I actually talked about the axis of symmetry. It didn't have anything to do with a kite. It had to do with, here, I'll just draw it. We are graphing stuff that looks like this. Isn't that crazy looking? All right, that's what we're graphing. All right, instead of just straight lines, right? We've graphed straight lines in here, right? Y equals mx plus b. All right, this is like y equals x squared. The axis of symmetry is the imaginary line that goes right down the middle of it. Right? You see the I don't know, what word am I trying to say? Yeah, anyway, do you see how they relate to each other? Okay, so this is an axis of symmetry. This is an axis of symmetry. So we talked about that in my Algebra 2 class yesterday. But really, we didn't talk about a kite at all. But that's what it is, okay? It's the one that kind of splits it right there, all right? But look which one the axis of symmetry is. It's not this one. This one is the one that connects the two equal sides. Do you see that? So they've got two equal sides here. That's the axis of symmetry. The other one, this one right here, this connects the two unequal sides. All right, we have a name for that, and that's called the crossbar. Kind of makes sense, doesn't it? Like if you're going to do pull-ups or something, right? You got a crossbar that's going, right? You can kind of think of it that way, all right? But what does that do? That connects the two equal angles. Remember, these two angles are equal to each other by that first theorem? Say the crossbar connects the two equal angles. The axis of symmetry connects the two equal sides. Okay, just remember which one's which. So we need to know those words to be able to do this theorem. So there's two parts to this theorem. The first one says that the axis of symmetry does two things. The axis of symmetry, which one is that? That's this one going up and down, right? Here's what it does. I'll put a little colon there. I'll put a 1. Here's the first thing it does. It bisects the crossbar. All right, let's mark that. Let's do it in a different color. So the axis of symmetry, this one going up and down, it bisects this little skinny one right here, the crossbar. So what does that mean? That means that this little bit right here is equal to this little bit right here. Everybody got that? Josh, did you see that? This little part right here and this little part right here would be equal to each other. That's what the axis of symmetry does. It bisects the crossbar. We good? That was easy. It does something else. It bisects something else too. So it does two things. Bisects the crossbar, and it also bisects the non-congruent or the non-equal angles. Non-congruent angles. Which angles are not congruent to each other? This top one up here and this bottom one down here, okay? But what does the axis of symmetry do? It bisects that whole big angle. So that means that this little angle right here is equal to that little angle right there, because it splits that angle into two equal angles. See that? What about down here? Yep, it splits these two angles down here, doesn't it? Does that mean that this big angle up top is equal to this little angle down the bottom? No, all right, because these are two unequal angles. These are your two equal angles. That's why it says it bisects the two what? Non-congruent angles, all right? So this is equal to this one is equal to this one. This big angle right here in red is equal to this big angle here in red. That's a lot of stuff to know about the kite, isn't it? All right? It's not that much, but it's a little bit. All right? So this little crossbar is being bisected. What about the axis of symmetry? Is that being bisected on a kite? No, it's not. Look, that's a lot shorter than that. So the crossbar does not bisect the axis of symmetry, but the axis of symmetry does what? Bisects the crossbar. All right. This is stuff you got to study. If you just come in here and just hear me say all this, even if you're awake, paying attention, writing this stuff down, that's not going to be enough. You're going to have to look at your notes. When you get your homework out and you're trying to figure out the problems, have your notes in front of you. Like, okay, this is equal to this. What's equal to that? You got to have your notes out, all right? It's very important. So with all that said, let's do an example, and we're going to put all this into practice. So what we're going to do right now in this example is very similar to what you're going to do on the homework, all right? Hope everybody's watching. Justin, you watching? All right. So I'll tell you what, let me just copy this one. I'm going to use that same picture. Oh, maybe I'm not. What did I... Oh, I thought I grouped that whole thing. Stupid me. Should I just draw it from scratch or just try to copy this thing? Might be quicker. Let's do this. There we go. Copy that. Guess I didn't group that whole entire... Oh my goodness. This is dumb. Dumb. All right, let's just do this. And let's do this. And do this. All right. I thought I took care of this earlier, but I'm not going to have, it really doesn't matter anymore because I'll be done with it once I finish this. Let's make it just a little bit bigger. All right. Here we go. Enough of that nonsense. Anybody still with me? All right. So what do they tell you? Let's label it. Look, they're kind of trying to be cute on labeling this. What did they label that kite? They labeled it kite. This is the kite. All right. And so it is a kite, so you know that these two are equal, and you know that these two are equal right here. And you know that that's a right angle. So when they tell you that's a kite, you can write all that stuff in there. If they tell you it's a kite, you can say that those two are equal, these two are equal, and that's a right angle. There's a bunch of other stuff you could say too. You could say that that's equal to each other. You could say this angle is equal to this angle. This equals angle to, if I could talk, this angle is equal to this angle right here. All right? So you know a bunch of stuff already before they even tell you anything. But they do tell you something particular. They tell you that angle XKE is equal to 55 degrees. All right? They tell you that, and they are going to ask for a bunch of stuff. Oh, forgot X. You're right. I did that in the last class. That's X where they intersect. Okay? Everybody see that? All right, they're going to ask for a bunch of stuff. Angle KTE. Let me just list all the stuff they're going to ask you to find. There's going to be 4 of them. Okay, KTE, TXE, XE, KEX, and one more, KET. So you're going to find all those angles. You're not finding any line segments at all. You're just finding angles. All right, well, let's start with the first one, KTE. Let's find out where KTE is. All right, there's K, there's T, there's E. So what are we looking for? I'm sorry, let's put what they tell you first. XKE is 55. Let's put that in there first. There's X right there in the middle. Okay, XKE. So there's X, there's K, there's E. So it's this one right here. That's 55 degrees. So they tell you that. All right. And let's change colors. We've got to find KTE. Well, K, say it again. Nah, there's no parallel lines here. Okay, so we're not going to use alternate interior because there's no parallel lines. This is K, this is T, this is E. Remember what's true about this whole big angle. What's true about this whole big angle and this whole big angle? They're equal to each other. Okay, so if this one is 55, this one's also going to be 55. Okay. So that was easy. We just look at it and tell. There's probably a little bit more to it than that, but that's good enough. All right. So where's TXE? Where's T? T is right here. There's X. There's E. Oh, that's an easy one. TXE. Everybody should just look at that and tell me the answer. What is it? Aubrey, you getting all this? 90. TXE is 90 degrees. Yeah. Okay. Because, well, it's not because it bisects, because that's a right angle. It's perpendicular. It's because it's perpendicular. All 4 of these, boom, 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 they're all 90 degrees. Make sense? Yeah, so let's write that down. 90 degrees. Easy. What about KEX? Let's find that. KEX. That's that little skinny one down the bottom left. All right, so this is what I'm trying to find right there. Say it again. Okay, there's an easier way to do it, though. We've discussed this before, not a lot, but we have talked about it before. If you have a right triangle, because you do, don't you? You got a right triangle here. You could go 180 minus 90 minus 55. But what's 180 minus 90 every single time? It's always 90, right? So whenever you have a right triangle, if you know one of the angles, how do you find the other one? What's the easiest way to find the other one? Just go 90 minus what? 55. Does that make sense? Because you're always going to go 180 minus 90, which is 90. All right, so it's a lot easier. Instead of doing all that, just going 90 minus 55. And that is what, 35? Yep. So KEX is 35 degrees. So that wasn't too bad, was it? It's kind of skinny, so let me write it out here, 35 degrees. All right, what's the next one? KET. Let's change colors. Where's KET? KET. I'm trying to find that whole. Okay, so this is 35. What's this little skinny angle right there? That's also 35, because remember, the axis of symmetry bisects that angle, doesn't it? So that means these two angles are the same. So if that's 35 and that's 35, talk to me. No, not 55. Right, 70, because it's these two 35s added together. So if I wanted to show my work, which you should do, you just write that down. Even if you can do it in your head, it's a good idea to write it down. And that is 70. 70 what? Degrees. Always put the degree symbol there. Okay? And there you go. You solve for all that missing stuff. What do you think? That wasn't too bad, was it? I kind of like it. It's kind of fun to me. I don't know. I mean, as far as schoolwork goes, right? I mean, look, I'd rather be out playing disc golf or something, okay, than doing this. Don't get me wrong. Right? Or doing a lot of other things. But as far as schoolwork is concerned, I kind of like the challenge, right, of them giving you a couple little clues, a couple little hints. It's almost like a mystery, isn't it? Right? Maybe I'm going a little too far, but it kind of is, right? And then you're like, okay, what do they give me? All right, now what am I going to figure out? Here's all the stuff that I know, right? Let's put it all together, put it into practice, and find all the missing stuff. This makes us think. Everybody listening to me? This makes us think. Nothing against English and history and all that, because there's times where you got to think in there, okay? But a lot of times, classes like that, what do? Like you read stuff, you answer questions, and it's all in the book, right? And you maybe give your opinion every once in a while, you write it. I mean, that's good. There's nothing wrong with that. But man, I like the way my brain works, and not everybody's brain works like mine, thank goodness. But the way I like to do schoolwork is to come up with a little bit of a challenge and come up and answering a problem, right? You got a problem in front of you, and you got to come up with a solution. I love that. Not everybody does. I mean, if you feel that way, then you're probably kind of a math person. But if you don't feel that way, maybe you tend to like other things. And there's nothing wrong with that. There's nothing wrong with being an English person or a history person. But or a culinary person, okay? It is satisfying. I agree. Ariel said it perfectly. He said it's satisfying to get the right answer. I love that response because that's how I feel. I feel it's very satisfying. Even though I know how to do this, I could probably do a lot of this in my sleep. It's still satisfying to come up with the right answers. Does anybody feel the same way? Yeah, I think a lot of you do. It is. Anyway, that's what I like about math. It's kind of fun. All right, so remember tomorrow, or not tomorrow, but on Monday, you're turning in 6.5a. And so you got to finish, remember, you got to finish 8 through 12? Okay, so finish that up. You'll turn that in. And then today's lesson is 18 to 25. This is part B, and it's numbers 18 to 25. All right? Yes. The test will cover chapter 6. This is chapter 6. This will be on the test. I don't know. Just go to section 6.5. If you go to section 6.5, just go to the back of the section. You'll see the numbers and the problems, okay? Everybody good? All right. Have a good weekend. And get your homework done. This is the last homework of the marking period. All right? So you don't really have any chance to turn this in late. Everybody hear me? Maddie, hear me? Okay? This is the last chance to turn it in before the marking period.